Hey everybody, hope everyone's doing well. My name is Arjun, and along with my teammates, Mathew, Simon, and Varun, we built something that we're incredibly excited to share with you guys. But before I start, I want to spend a little bit of time talking about something that's been on everyone's mind this year. In today's climate, where COVID cases are spiking, the importance of wearing a mask cannot be overstated. Currently, many small businesses are beginning to reopen, but they face the challenge of enforcing both social distancing and mask wearing, all while running their business. Enforcing these rules are paramount to maintaining safety in today's world. Unfortunately, where there are rules, there are people who break them. As throughout the year, we have seen the rise of people who deliberately disobey mask mandates when entering into stores. These anti-maskers not only disrespect and waste the time of the business owners, they also pose a health risk given today's climate. This problem got us thinking about how we can use our passion for computer science to address an issue that's more prominent than ever. So we came up with Maskif.ai, the AI-powered smart lock designed to keep anti-maskers out. Imagine you're a business owner and an anti-masker is walking up to your door. Currently, there is nothing you can do to stop them, as they possess the ability to enter the store and cause issues. Maskif.ai solves this problem using computer vision to scan the faces of every customer entering into a store. If Maskif.ai detects a person who's not wearing a mask, it automatically locks the door and won't open it until they decide to comply with the rules. Thus, Maskif.ai eliminates the hassle of the arduous and oftentimes fruitless task of arguing with anti-maskers, allowing business owners to run their business in the safest way possible. Now, let's spend a little bit of time examining the core components that power Maskif.ai.
So the first component is the computer vision side, which will take the input from any camera feed and run it through our computer vision backend. So the first step is to extract the faces from the image using a HAR cascade classifier, which looks for face-like features and returns a box surrounding that face, as you can see in the image. We then trained a convolutional neural network on thousands of images to recognize whether each face that's returned is wearing a mask or not. Depending on the result, the app takes the appropriate action of either locking or unlocking the door.
And of course, we know that computer vision isn't always perfect, right? However, Maskif.ai actually transcends the accuracy of the underlying computer vision technology with our processing algorithm. Instead of just considering what it has seen at a specific instant, right? Maskif.ai actually accounts for what it's seeing over a period of time. So this means that, even if the underlying classifier isn't always accurate, no big deal, because Maskif.ai can always deliver accurate results, classifier or not. And in order for Maskif.ai to achieve societal impact on the scale that we want, it's important that anyone should easily be able to implement Maskif.ai in their own business. And to this end, we had to make Maskif.ai work with as many locks as possible. However, there are tons of smart locks out there. How do you actually go about adding support for each and every one? It's a Herculean task. So we leveraged Google Assistant, and through that, we were able to integrate any lock that worked with Google's tech. We're proud to announce that Maskif.ai can connect to and works flawlessly with any smart lock that a user might own.
So in order to integrate this mask detection into a live webcam, we developed an iOS app that many iPhones can use. We created a basic front end using Swift and have a button to stop and start recording. While our interface is relatively simple, as you can see here, the bulk of our effort here was spent in working with Apple's AV Foundation framework to capture and stream this data to the backend. And I'll pass this off to Simon to explain the details.
So our essential idea was to use WebSockets to set up a continuous video stream. And using the socket.io protocols, we were able to transfer the video to the backend, and then the backend was able to transfer any data to the front end, such as the bounding boxes.
And obviously, not everyone has spare iPhones just lying around that they can dedicate to Maskif.ai, and we get that. So in order to achieve our goal of making it possible for anyone to use Maskif.ai, we needed to create an alternative input system. So Maskif.ai operates smoothly with any webcam a user might have. And this just takes out the need for a spare iPhone altogether. Obviously high-end webcams, wireless webcams work exceptionally well, but it can even work with generic budget webcams you can get for less than $10 online. You can even connect it to the integrated webcam on your laptop, and it should work.
All right. So there are a few places where we see improvement for Maskify. The most straightforward addition would be creating an Android app that streams video in a similar manner to the iOS app. Another thing we could do is we could have Maskify broadcast a message about mask wearing, which can help remind patrons who may have forgotten to put one on, but are willing to do so when prompted. Lastly, we think there is room for creating a more inexpensive hardware lock solution. This concludes our presentation. Thank you for listening. And does anyone have any questions?
Hey guys, yeah, I can start with a question. Great presentation. It looks like you guys have built some pretty cool modular technology that has like kind of individual, pieces that can work nicely together. Can you see this technology being integrated into something else? Like maybe, requiring people that need to wear a uniform for work as a medium, or have you guys thought of maybe integrating this in another way?
Well, currently our classifier is dedicated directly to masks, right? But the cool thing is, first of all, since we integrated Google Assistant, Google Assistant works with tons of devices, right? Not just locks. So we actually went over this in our video, but there's an example where, let's say you want to turn the lights off when someone without a mask walks by, right? Or literally any device you can think of, really. And it works completely fine. And actually creating a different classifier for a different thing would be possible as well. And we get that working with Google Assistant.
Yeah, and just kind of adding on that, the way that our neural network is built, it's really simple. If anybody wants to check out our GitHub repo, just to add in the photos of things that you want to classify into 2 different categories and train it. So if we wanted to classify something like people wearing a uniform for work, it really shouldn't take that long given our current architecture.
Thanks for clearing that up.
I have a question, maybe this is for Varun. Can you elaborate more on how your algorithm overcame some of the typical challenges with classifiers? And I think you mentioned that it learns over time. If you wouldn't mind just elaborating on that a little bit, that would be great.
Right, so essentially, we can't accurately classify every frame, right? Obviously, even if we try to create the most accurate classifier ever, occasionally it'll fail. And that's completely fine, because the fact of the matter is, if someone's approaching your door, they're not going to just barge in half a second, right? They'll take time to walk up, and you'll have a bit of time in which you can classify their face, right? Figure out exactly what's going on. So we took advantage of that fact. Basically, what happens is we take the frames over a set period of time. Mm-hmm. I think in our case, it was something like 12 to 15 frames. And we say, hey, if you see someone without a mask in 2/3 of these frames, then lock the door. And if they walk away and you see someone, I think it was 4/5 of the frames, right? Have a person if everyone's wearing a mask in 4/5 of the frames, right? Then you can lock the door again. So the algorithm has a unlock the door. So the algorithm has a predisposition to locking the door, right? And preventing anti-maskers from getting in.
Okay, thank you.
Thank you. This is exactly what I was thinking. I mean, many of people in need of this kind of things would be small stores owners, right? They have a small place, therefore now with the COVID situation, actually, and also for their own business, they tend to leave the doors open, yeah? But then using your solution essentially would mean that people would need to close the door, yeah, before the people come. And this is what, which is not good for the business and for the virus, so that you need circulation. And how do you want to try to prevent this situation instead of using the lock, for example? Yeah, I know you have this speaker support. This is great, a very good idea, I think. Yeah, but what do you think about this? And again, thank you for your project. I like it.
Yeah, thanks for the question. I agree that for some businesses and how they operate, it could be a problem to have the door closed. But I do agree that at times that could cause problems with COVID and this circulation problem. But I do believe that having the door closed in this way and then not allowing people to enter is likely still the best possible solution in most cases, in that a lot of small businesses, they already might do close the door, for example, if the outside is really cold. So, you know, they have to, they close the door in order, in most scenarios already. So as a result, I do believe for the most part, this current solution with locks will work. And in the situations where it doesn't, I do believe the speaker support is likely the best way.
I have a question. I took a look through your GitHub repo and I saw that your training data set was actually, it looked like you created the training data set yourselves. Can you talk a little bit more about how you kind of came about that and, you know, what went into that process? It looked like you were kind of like relaying fake images of masks onto, you know, images of faces.
Yeah, so that was actually, we didn't actually make those images that way. It's just the data set that we downloaded that had it in that fashion. I think we also tried to include some more images that were of like different color masks at different angles, whatnot, just so we could have a little bit more diversity, more flexibility in our model. But definitely, if we wanted to go about making our model stronger, I think adding in more data and feeding in more examples would be the way to go.
Cool. And I think that's time for the second presentation. So thank you, Maskif.ai.
At the end of the day, we decided to go for one, which the name is Maskif.ai. Why did we decide to go for Maskif.ai? And congratulations, guys. I really liked your project personally. We think you had all the 4 points that we were looking at. You had them really very well represented in your project. You were learning all the time. You use different technologies from the Google Cloud platform. You can be really very proud of it. You really got a project, a concept project behind this. You are making something impactful. You are making something that can be very useful, and particularly in this situation today. We are living extraordinary times, and extraordinary times need extraordinary projects and extraordinary people that can do things. Really, congratulations. Thank you very much for having been at the Yale Hackathon.